Equilateral and Isosceles Triangles by Aisha and Audrey.
Alright, so we're going to explain what an isosceles triangle is. So an isosceles triangle is a triangle where two sides are congruent, meaning two sides are equal. And we represent the two sides that are being equal with two dashes. The two sides that are congruent are called the legs. The side that is not congruent with the other two sides is called the base. We represent them with two dashes to show that it's a different length than the legs. The angles that share a side with the base are called the base angles. The angle that is in between the legs is called the vertex. Now, when we solve the area of an isosceles triangle, we often draw something called the altitude. And the altitude is drawn from the center of the vertex down to the center of the base. And it creates two right equal triangles. Okay, so now we'll discuss the isosceles triangle theorem. The theorem states that if two sides are congruent, then the two opposite angles are also congruent. And let me show this on this triangle. So let's say this side is congruent with that side. So that's opposite angle. So this opposite is going to be this angle. And then this one is going to be this one. So these two angles are also congruent. Now the reverse of this theorem is saying that if two angles are congruent, then at least two sides are congruent as well.
Equilateral triangles. Equilateral triangles are triangles that have all equal sides and all equal angles. This can be represented by the same dashes as used earlier to show congruency. So if you see an angle and if you see a triangle and you know that it's an equilateral triangle and they give you one side, you already know that all the sides are going to be the same. And same thing with the angles. Now, as for the equal sides, we know that they're all going to be equal no matter what. And for the angles, so all triangles have a total angle measure of 180 degrees, right? And since all the angles have to be equal on an equilateral triangle, that means for all equilateral triangles, for all of their angles, it will be 60 degrees, no matter what kind of triangle, no matter what the length of the sides are. Finding area. So first, let's review the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared, and it only works for right triangles. So this theorem will be very useful when trying to find the area of different triangles, so that are not necessarily right triangles. So for example, this is an isosceles triangle. It has sides 3, 3, and 2. So we know all the sides, but we need the area. So first we need to solve for h. H is the altitude, not the amplitude. So it's just a line that goes straight from the top of the triangle to the bottom, and we'll label that h. So since we need, to find the area of a triangle, it's base times height over 2, right? So we have the base, it equals 2, but we still need the height. So when solving for the height, since we've split it right here, so we know that this side equals 1. So now we have a whole new triangle, a perfect right triangle that we can use the Pythagorean theorem for. That the side is 1 and the side is 3. So we can say that 1 squared plus this mystery side h squared, equals c squared, which is just going to be 9 because it's 3 squared. So we solve for that, and we know that h is going to equal the square root of 8. So now that we know the height, we can find the area. So the area will equal the square root of 8 times the original base times 2. So the answer is going to be 4 root 2, because we factor out the 2's from the 8. Make sure you remember the other part of the formula, which is base times height over 2. Do not forget the over 2. So the answer is actually, the answer of the area of this triangle is 2 root 2.
Okay, so our first example, we're going to find the area of this isosceles triangle. First step, we have to draw the altitude. We're going to label this H. So this is now a right triangle. And now these bases are now 3 each. So using our Pythagorean theorem, we can state that h squared plus 3 squared is equal to 5 squared. Now let's simplify this a little bit. So it's h squared plus 9 is equal to 25. So we want to get h alone, so we're going to subtract 9 from each side. So we're going to subtract 9 from this side and 9 from that side. So now we'll have h squared is equal to 16. Now we have to take the square root of h, so we can get h not h squared. So let's take the square root of this and the square root of that. So now I'll have h is equal to 4. So now we can find our area. So the area function is area equals base times height over 2. Alright, so we have to make sure that we use the original base, which is 6, not 3. So we'll do 6 times 4 all over 2, which is equal to 24 over 2, which is equal to 12, which is our area of this triangle. For our last example, we're going to find the area of an equilateral triangle. And same as before, we're going to draw the altitude, right triangle, and write h. So now we have to use Pythagorean theorem, so we're going to do h squared. Now we're going to do plus 2 because now these bases are each 2 on each side. So we're going to do h squared plus 2 squared is equal to 4 squared. So now I'm going to simplify this a little bit. H squared plus 4 is equal to 16. To get h alone, we're going to subtract 4 from both sides. Also, we'll have h squared is equal to 12. And so we have to do the square root of h, so we can get h, not h squared. So if h is equal to the square root of 12, and we can just leave it in the square root since it doesn't really simplify into anything. So now we'll use our area equation. So we'll have area equals base times height over 2. Remember, we have to use our original base. So we'll have base, so 4 times the height, which is the square root of 12 all over 2, which is the same as 2 root 12. And if we want to simplify this some more, we'll end up having 4 root 3.
Thanks for watching.